So we're going to start by looking at some of the components that I've identified and could be used in the Hacky application. So first off, this is a plug-in module. It doesn't really come pre-wired, but you can put it in line. Really helpful for testing if you don't want a permanent installation, but overall it's not something you can run around with, but yeah, good for a quick test because it just sits in line. You don't have to do anything else. Normally for the Hackies I'm running one of these, which is a LCD display which shows power, voltage and stuff like that. It's helpful, but for it to be able to work you need a shunt in line on the high side typically for that, and that's one of those fellows. Now the shunts are available in a range of different values, and typically they're in the order of 0.001 of an ohm, and you put the power on the big terminals and wire off the little terminals on those. So it's good, it's cheap, it's easy to do, but still doesn't give you that much flexibility. So really for the application I'm thinking of, I don't want one of those fixed power meters, I want something more flexible. So the way I'm going to do this is use an Arduino. Now Arduinos come in various shapes and sizes. That's an Uno, and it's great for breadboarding. You can plug in easily down the sides. You also put what's called shields, which provide different sorts of I/O onto that as well, but generally that's a sort of prototype. Normally I use a Nano. These are great, these are really cheap and readily available, and that's a starting point for the current monitor. So the next step is really, what current monitor? Well, we can do a straight replacement of the current power meter with the Nano, along with a simple device to link into their ADC, so their analog to digital converter. So you can take the shunt sitting there and use something like a INA219, which is a DC current sensor. So that little chap there, and that can be wired in. Now that works okay and can do the job, but still requires the shunt in line. These are interesting in that they have a 0.1 ohm resistor there, and there's various blogs on YouTube which show using essentially that along with the current shunt. Now that's one way, and I did try it out, but at the end of the day I'm trying to get rid of the current shunt. Now there's various devices that can be used for that, so we'll have a look at what they could be. So you could use one of those bad boys, and that's a Hall effect current sensor, and you solder on to those big tabs there. You can get them on modules as well, which come with sort of bolt on, and the current obviously flows through there, and you've got an analog value out, which allows you to obviously replace the shunt, though you're still really cutting the wire, so you can solder onto those. And given the sizes of the wire that we're talking about, so 8 AWG, then that's quite a bit of wiring that needs to get done. So although very good, that's not the route I've chosen to go. So the route I've chosen to go is one of these. So this is a Winston, it's a WCS1700 current sensor, and it gives an analog value out depending on the current flowing, and it's bi-directional. So this one is marked up at 70 amps, so it's 70 amps either way, so 140 amps. You can go bigger or smaller, but these are readily available. You can get them as a bare PCB as well, and really what happens is the wire passes through that hole, so you're not cutting the wire specifically for the sensor, passes through there, and it's a Hall effect on there. So that's a route I'm planning to go for the current sensor, but it's a few more things that really I want to go for to make this a bit more usable, a bit more friendly to work with. So we'll just look at some of those. So firstly, I want a display, and display here is a small little OLED display. You can get them bigger. Here's an example of a bigger one, and these are very easy to use. So that gives me a display that gets me up and running from there. The next bit that I want to look at is something that overcomes some of the limitations of the Arduino itself. So the Arduino itself has a 10-bit ADC in there. That's great, but it's not necessarily the highest resolution. So you can get different external ADCs that run on an I2C interface. Here's an example. It's an ADS1115, and this is a 16-bit ADC, so it's pretty compact, and it has 4 channels, so you get high resolution on 4 channels, which I think is pretty useful, especially with things like the Hall effect, where you have to do a level calibration against the 5-volt rail. So that can be definitely beneficial. So I wanted a temperature sensor for the fuse, so I could read what the fuse was running. So I looked at various different ones, and one of the easiest ones to use is a DS18 B20. Those obviously pretty small, nice and easy to wire up, so that's great. So I'm going to use those. So an area I've been looking into is how to store this data, and there's lots of nice little things available for Arduinos, and they can be used with other microcontrollers, but in this case you can get a battery backed up real-time clock and SD card reader, so they look like that. You can get variants as well, which are available for just nanos, and we'll look at one of those now. So instead of that package, you can have a package like that. And what happens is you take your Nano, plug it into here, and it starts the real-time clock on there, as well as underneath there's an SD card reader. So they're quite funky. Might look at using one of those instead. The final sort of bit out of this whole collection of parts and bits I've been looking at is providing a power supply. Now Hacky's run at 48 volts, and that's too much really for your any of these pieces here. They're looking for, I think the Nano runs on something like 6 to 9 volts. So I've been using these buck converters, and we'll just have a look at what one of those looks like. So that's a buck converter, and it takes a voltage in and gives a voltage out, and simple as that. Now, buck converters have the potential for being noisy, so it's something we're going to have a look at. Electrically noisy, which might affect some of the readings, but we'll get into that once we start running some testing. So that overall is the set of parts. So our buck converter, our real-time storage, our display, our current sensor, our Arduino. Those are the key components that will go forwards with, along with temperature sensors, and the one bit I'm not showing on here is a rotary encoder that I'm going to use for changing the display so that I can scroll through. Because it is a small display, I can scroll through and show things as I want, either runtime or afterwards, along with a couple of LEDs which I can program up to show things like hitting sort of current limits or hitting temperature limits as well.